So the first step is you draw your picture. Get it. Make sure you understand it, like completely understand the problem, what it's asking, what you have, and what you're looking for.
So the next one is a baseball player. A baseball player's friend of yours wants to determine his pitching speed. You have him stand on a ledge and throw the ball horizontally from the elevation of 4 meters above the ground. The ball lands 25 meters away.
So he hits it. 36. Cool. How high is the ledge?
4 meters.
4 meters. That's what the pictures do. They help understand what's going on.
Good thing we don't have to account for how tall he is.
Yeah. Like that.
Our acceleration in the y direction, is that 0? No, it's -9.8.
Yes. Because it's in free fall, as gravity, there's nothing else acting on it. So your acceleration is equal to gravity is equal to -9.81 meters per second squared. Alright, that's better things. So the first step in one of these problems is to draw your picture. Make sure you have everything figured out. You don't really have to label you can, it's good practice too. But if you know what's going on and you understand it, then you're good. So it's in that he throws it horizontally? Yeah? Yeah. So there's no angle, that's good. And what are we looking for? How fast it was.
Yep.
And so in order to do that, I wrote down all the equations. I wrote VF is equal to AT plus velocity initial. A is equal to constant.
Okay.
And then I wrote y final is equal to 1/2 a times t squared plus velocity initial times t plus y initial. And then I wrote velocity equals distance divided by time.
Distance.
And from what I understand, we know that y initial is 0 and y final is 25. I mean x initial and x final. And then y initial is 4.
Okay.
And y final is 0. And we have the acceleration of y is -9.8. We know that the velocity initial, or velocity y final, is going to be constant.
Okay. So we can find time.
And
In the x, that's what we're looking for?
That's what we're looking for.
Okay. And it's 0 for the velocity in the y direction.
Exactly. So it's a free fall problem, so then we find that the time is equal to 0.81 seconds. So if you were to drop a ball from 12 meters, it would hit
the
how much?
time is actually 0.03. Right, 0.903.
0.903. Okay.
Because you have to square root it.
0.903. Perfect, yeah. So it would take 0.9 seconds to get the ground from 4 meters above. Like that, just dropping it. This is where it gets trippy. The time for the ball to get from here to here, oh that's 4 meters, I'm sorry. This is 4 meters. The time for the ball to get from here to here is 0.9 seconds. The time for the ball to get from here to here is also 0.9 seconds. That's the trippy part.
From here to where?
From here to here. So if it takes 0.9 seconds to get from here, we have time. And if it takes 25 meters to get from there to there, then we can use this equation to find our x, or velocity.
Ironically enough, we could use the x final equation that gives us the same thing.
Yeah.
Because of the zeros.
Ah, look at that. That's awesome.
Okay, so my big thing is with all the kinematic equations, I kind of struggle.
Okay.
Just the equation in general.
Yeah.
So, if I am understanding this correctly, the YF means Y final, so
Right there.
Just basically, since this is being thrown horizontal, we don't even need to worry. Just from there to there, I guess, right? It's-
Yeah.
So just the fall in y.
Okay.
Is that correct?
Yeah. The
So
fall in y.
1/2 times at squared, acceleration times squared,
Mhm.
plus initial velocity,
Mhm.
the times t? Or
Times t, yeah.
Times t, times time, plus
The y naught. So the starting position and the ending position. So it's starting here at 4,
Mhm.
and then it's going down to 0 at the end.
Mhm.
Start is 4. That's 4, and then the final
This
is
is 4?
yeah. And this final is 0. Because you're
Okay.
going from like on your number line, like this, from like 1, 2, 3, 4. You're going from 4 to 3 to 2 to 1 to
Mhm.
0. So that's how you look at this whole thing. Is you look at it
Okay.
as a giant graph.
So from here, so the final is going to be 0, so we know this is 0, right?
Yes.
And the y naught at the beginning was 4.
Mm-hmm.
We don't know the time, correct?
Yeah.
We're trying to find that,
And we have acceleration.
which is the gravity, negative 9.8, right?
Mm-hmm.
Okay. Okay, I guess when it's drawn out like that, I can understand.
Yeah.
When I see where it goes.
One of the best things that I did is I'd have all the kinematic equations on the note card, just
Mhm.
the 3 of them, just through 3, because I'd use them every single problem. And I'd look at them, and I would be like this: v final squared is equal to v initial squared plus 2ax, then v final equals v initial plus at, and then this
And,
one.
plug in the time.
And I would look at them,
What did I do wrong?
and I'd be like,
Where'd you
do
plug
we
it
have
into?
v final?
Do
not.
Okay.
Okay.
You
Do we
start
have
out
initial?
with
Yes. Do we have
um,
acceleration?
Basically
No.
what I do,
Y
I
final.
always just write
You
them
start
all
out with the y
out.
Oh, good.
equation.
Like,
I make
So the
these
y
headings,
final,
yeah.
which helps.
because
When you look at
we
your
don't know
grids,
the acceleration
First,
for
you're
x
looking at what I
final.
don't have.
Or
What
the-
you're looking for.
because,
Looking for
I mean,
time.
Because if we
Mhm.
divide it by,
Um,
because the acceleration for x is
And so you're
0,
like,
Yeah.
so we
will
use
that
the
help us?
y.
No, it
Well,
will not.
y
Will that help us?
final
Kinda.
is
We look for
0.
time, but we don't have
Mhm.
that, so we can't use that. So we look for that one.
Okay.
Like, hey,
because
you have
this
time,
is
and you have
0,
everything else.
25.
Okay.
I mean,
I
this
think
is
my
25,
big
0.
problem is like once I know what equation to use,
Mm-hmm.
then I'm good. I guess the problem is just the equations at their basics, and then how do I know which one to use? Like, it's
Well,
just-
it doesn't hurt to use them all.
Okay.
Like, it'll be, obviously, it'd be more time consuming, but you
So
could
you
put,
could use all.
you could put all of them, yeah. Like, we could do this. We could find v final and v final. Okay, so let's say, we don't know v final.
There's one more part to 46.
What is it?
We have to find the speed, the highest and lowest speeds if he threw it 50 degrees below the horizontal and 5 degrees above. 5 degrees below and 5 degrees above.
Okay. Yeah. Well, like what we were saying, real quick to finish it up. So let's say you have this. You have v is equal to that. So you could put this v into here. Like v naught plus at squared is equal to v naught squared plus 2ax. You could do that.
Okay.
That's just more work for you. You have x, you have a, you have v naught, you have v naught, you have acceleration, you could find t.
Yeah. Okay. That makes sense. Okay.
So we are
just
looking
need
for,
pound them out more.
so what did we get for time? No, what were we looking for? Velocity?
Velocity was 27.66 meters per second.
So they got that from putting your time here. X and time. Perfect.
So the question next is, as you watch him throw, the pitch seems to vary from 5 degrees below the horizontal to 5 degrees above the horizontal. What are the lowest and highest speeds at which the ball might have left his hand? So, we're given theta. From theta,
Is it between from 5 to 5? Like he's throwing it at every single angle?
no, it's either at 5 degrees above or 5 degrees below.
Okay. Okay. What are the lowest and highest speeds with which the ball might have left his hand? And are we going the same?
Yeah, I think everything's the same, just the 5 degrees.
Cool. Well, just from looking at this, I'm going to say that the fastest is going to have to be right here at the -5 degrees.
Yes.
Because if you throw it at +5, then you can kind of just lob it. Because then you have that extra lobbing power to arc it over to hit the spot. If you have -5 degrees, then you have a lot less arc to work with. You have to get it like a straight shot. And in order to get to be a straight shot, you have to chuck it. Like really hard. That's my guess.
Yeah, makes sense.
Makes total sense.
So now we have to find the values.
So that is my guess. You can try both of them. You can try that one too.
But we have to find the lowest and the highest speeds.
Lowest and highest.
We're looking
Oh,
for
we'll do both of them.
speeds
Yeah,
Yeah.
that's good. The velocity, yeah.
at
Check.
that angle.
Check it. Okay.